Okay, good evening, 3-6. In this video, which is part 3 of my self-directed learning series, I am going to talk about the equation of a line. Okay, so just to recap what we have done so far in part 1, actually we have just talked about the distance between 2 points, right? So if we have 2 points, you now know a formula of how to find the distance between 2 points. Okay, so that was in part 1. What did we do in part 2? Part 2, we actually talked about the gradient of a line. Okay, the gradient of a line. Alright, and even though it's gradient, it's measuring the slope of how steep a line is. Okay, for example, a horizontal line has gradient 0. Okay, and this line probably has a gradient, okay, maybe about less than 1, could be about half. Alright, there's actually another way to think about gradient. You also can think of gradient as direction. Okay, what do I mean by that? Because for part 2, let me just elaborate. We've got things like negative and positive gradient, right? So for example, if a line has gradient -1, okay, your line probably goes like this. And if your line has gradient +1, it goes like this. Alright, so in a sense, a gradient can tell you the direction of a line. Okay, so you know how to find that. There's a formula for that. And now let's actually just talk about part 3. Alright, part 3 actually talks about the equation of a line. Okay, so maybe this is going to be a bit more difficult than either of the two parts, so please listen carefully. What is the equation of a line? Okay, and I'm going to write it out here for you, the equation of a line. Okay, the equation of a line is this. Okay, y equals to mx plus c. Okay, so now let me break it down for you. So this is the general formula. Okay, general. Okay, and let me give you a few examples of how it looks like. Okay, so there's this line here, y equals to 3x plus 5. Okay, this is a more specific example. Okay, so this is the first example. Okay, maybe another example would be this. Okay, y equals to 4x minus 4x minus 6, let's just say. Okay, this too is also a specific equation of a line. Alright, so when we look back to our general equation, okay, this m here actually has to be a number. It has to be a number when we are talking about something a bit more specific. Okay, so this m has to be a number, and this m actually means the gradient. Okay, this m means the gradient, and this c actually means the y-intercept. Alright, so this c is the y-intercept. Okay, so some of you ask, wait, this is new to me, I don't understand. Y is the equation of a line, the gradient times x plus the y-intercept. Okay, so maybe you can look at it this way. Okay, so let's say if I've got a GeoGebra here, let's talk about any line. Okay, the reason why the equation of a line is y equals mx plus c is that let's talk about the c first. Okay, c means the y-intercept. Okay, so let's say we have a straight line graph. Okay, and I hope you understand that any straight line graph in the xy plane, okay, any line, it will always cut the y-intercept. Okay, unless it is directly vertical, there's no way around it. Okay, unless you have a totally vertical line, okay, like this line, x equals to 4, a line is always going to have some form of y-intercept. Okay, so this is a line which has a y-intercept at 2. So why does the equation of a line actually mean, how can it be defined by the gradient and the y-intercept? It's because after you have the y-intercept of a line, all that matters is the direction that it is going. Okay, so let's say this line, which I haven't drawn yet, is got a y-intercept of 2. But do you realize that after you settle the y-intercept, let's say this y-intercept is at 2, then the gradient will actually tell you the direction of the line. Okay, so once you have the y-intercept and once you have a gradient, you know everything there is to know about the line. Okay, so so this line, what is the equation of this line? Okay, the one that I am drawing right here. Okay, so okay, let's figure this out. Okay, so if we look at this line which I just drew, what exactly is the equation of this line? Okay, I need to know two things about this line first. Okay, first I actually need to know what is the y-intercept. Okay, the y-intercept of this line is actually 2. Okay, so okay, so for that line, the y-intercept, okay, was 2. Okay, so this line here, the y-intercept was 2. You can see because that's where it crosses the y-axis. Okay, so y-intercept is 2, and the gradient of this line, okay, you could calculate it. You've got 2 points on the line, so it's easy to calculate, but I'm just gonna go ahead and tell you that the gradient of this line is actually what do you call that, 1/4. Okay, so you can calculate it later if you want, but trust me, the gradient of this line is 1/4, and I actually can tell because I'm looking at rise over run. Okay, and I'm sure it's positive. Okay, so in this case, I'll write down the y-intercept is 2 and the gradient is 1/4. Okay, so this actually means that now with these two things, I just need these two numbers, I can write out the equation of the line. Okay, and if you notice that in my previous examples, there was always a y and an x. So when I'm going to write down the equation of a line, there's always a y and an x. So the equation of this line is y equals to 2. Where did the 2 come from? It's here. 2x plus sorry. Okay, so y equals to, no, that was wrong. Y equals to 1/4. Okay, x. Okay, gradient is always the coefficient of the x plus a 2. Okay, so that's this line here. Okay, the equation of this line is y equals to 1/4 x plus 2. Okay, alright. So now that you know how to find the equation of a line, let's just go through several simple examples first. Okay, let's just do one more. Okay, so let's say you know the y-intercept of a line, okay, happens to be let's say -5. Okay, and the gradient of the line, okay, you know the gradient of the line, okay, is actually let's say -2. Okay, so now there's actually only one line you can draw using these two pieces of information. Of course, bear in mind we are always talking about straight lines. Okay, so the gradient of this line, given these two pieces of information, I know it's y equals to -2x plus -5. Okay, but of course, like I said, y equals to mx plus c. That's the general formula. Okay, maybe I'll write it down in another color. Okay, general formula is y equals to mx plus c. So in this case, my m is -2 and my c is -5. Okay, so this is the gradient of a line, but of course, you look at this plus and -5 here. If we were to simplify it, we would just write y equals to -2x minus 5. Okay, so this is the gradient of a line. How does it look like visually? Okay, so let's try and find out. Okay, first thing I know is that the y-intercept was at -5, right? So let's just put a point here. Okay, and the gradient was -2. So how would the gradient of -2 look like? The line would be going this way, right? So I can draw a line. Okay, and the line, okay, it would be about 2.5, something like that. Okay, oh, this line isn't exactly -2.5. Okay, we could just shift this. Okay, -2.5. Okay, give me a moment. I'm using my mouse to shift this. Almost got it. Okay, but you get the idea. There you go. Okay, so this is the line of y equals to -2x minus 5. Alright, So for right now, I'm just going to pause the video and keep a lookout for part 2.